Now the electromagnetic spectrum, it extends from the high energy gamma rays to the low energy microwave and radio waves. And the energy of the radiation is given by the equation E is equal to hf, where E is the energy of the electromagnetic radiation, h is the Planck's constant, and f is the frequency of the radiation. As you move from high energy gamma rays towards the low energy microwave and radio waves, you see that the wavelength increases. Now, what is wavelength? Now, wavelength is the distance between two successive maxima or minima. So as you move from high energy gamma rays towards the low energy microwave and radio waves, the wavelength increases and the energy decreases. And as you move from low energy microwave and radio waves towards the high energy gamma rays, the frequency increases. Now frequency is the number of wavelength units that pass through the fixed point in unit time. So as you move from the low energy microwave and radio waves towards the high energy gamma rays, not only the frequency increases, but also the energy of radiation also increases. Now one complete wave is constituted by one maxima and one minima. So a complete wavelength unit is one maxima plus one minima. So hence the frequency will be the number of wavelength units that passes through the fixed point. Now here in this case you can see around 2 waves have passed through this fixed point, and hence the frequency will be 2 Hz. So 1 Hz will be 1 cycle per second, 2 Hz will be 2 cycle per second. Now the infrared region, it comprises of near region, mid region and the far region. Now of these 3 regions, the middle infrared region, which provides wavelength ranging from 400 to 4000 centimeter inverse, is of analytical interest as it is utilized for structural elucidation and functional group determination. Now the infrared region in the range of 400 to 4000 centimeter inverse, it induces bond vibrations. That is, it has the sufficient energy to bring about both bond stretching as well as bond bending. So that is the significance of higher region. So it can induce bond vibrations like bond stretching and bond bending. Now wave number is the number of waves per centimeter. It is reciprocal of the wavelength and hence the unit centimeter inverse. So wave number is the number of waves per centimeter of the given wave. Now generally IR absorption peaks in the spectra, they are mentioned in terms of wave number. That is, they usually consider the reciprocal of the wavelength and thereby end up with the unit of centimeter inverse. So why is that? Why do they consider the wavelength unit in wave numbers and not in meters or centimeters? Now reason is that now the wavelength unit in terms of centimeter will be in decimal values, and it will be very difficult to handle these small values with decimals. So when you take reciprocal of this, say for example, the length of the wave is 0.002 centimeters, and when you take the reciprocal of this particular value, you'll end up with a huge number, that is 500. So when you take reciprocal of this number, you end up with 500 centimeter inverse. So which is more convenient to handle? So definitely it will be the huge number that is more convenient to handle rather than the values in decimals. So when interpreting IR spectra, organic chemists often prefer using wave numbers instead of wavelengths. Now this preference for wave number units, it can enhance the convenience and clarity in discussions related to IR spectral analysis. So when the organic chemist is trying to interpret a particular spectra, these used values in centimeter inverse helps him to carry out the interpretation easily. So it's always better to use the wave number units. And that is why IR absorption peaks are mentioned in terms of wave numbers and not in wavelengths.